Hello, welcome to Lab 2, Drop the Charge. We were a group of 4, Camille, Intia, Rosina, and Melanie. In this presentation, we will experimentally determine the charge transferred when unrolling tape and the amount of excess charge on a tape within an order of magnitude. So for the experiments, we use the following materials. We use a roll of clear tape, a ruler, a flat surface, which was a table, stackable videotapes, and then cell phone to record the experiment. On the picture shown here, we can see that there's also a balloon. So we know that the hair is positive, and when we rub a balloon against the hair, the balloon becomes negative. So that would be a really great way to confirm any assumptions that were made regarding the charge of.
So first we measured out approximately 20 centimeters of tape, which we then firmly placed on a flat surface. In our case, the tape was in our lab room. This will be our base tape for our experiment. We then measure out another piece of tape, also 20 centimeters, which will then be placed directly on top of our base tape and smoothed down. The top piece of tape will be called our U-tape. In order to charge the U-tape, we must quickly and carefully remove the U-tape from the base tape. After it is charged, we brought the U-tape close to my hand. As you can see in the video, the tape is attracted to my hand. This action tells us that the tape is negatively charged because the tape is attracted to my hand due to polarization. We also have to be careful not to overhandle the U-tape. If we overhandle it, the tape will no longer become attracted to my hand. This is because the tape loses its charge due to overhandling. This also tells us that the U-tape is negatively charged because it becomes attracted to our positive hand, and opposite charges tend to attract.
We prepared 2 U-tapes that were both around 20 centimeters long. Then we placed 2 base tapes on a flat surface, the table, and then we placed 2 U-tapes on top of them, firmly and smoothly. Then we removed the U-tape in a quick motion away from the body to avoid touching them, and that would make it lose its charge. Then we brought the 2 U-tapes together, and we could see that they repelled each other, and the reason is because they have similar charges acting on them.
So now we're going to do an experiment with 2 charged U-tapes. And for this part of the experiment, we stacked 2 stacks of, in our case, videos or DVDs. And after we charged 2 U-tapes, we placed one of them on top of the stack. And as you can see in the video, we take the other charged U-tape and place it underneath the charged U-tape between the 2 stacks of videos. And it's pretty slight, but you can see in the video that the charged U-tape that's placed on the stack of videos, it rises upwards slightly. And we estimated that it rose approximately 0.05 meters. We also discussed between our lab group that the humidity in the room probably tampered with how big of a result we got. In the room that our lab was in, there was a humidifier to create a drier environment. But as you can see in the video, we still didn't get that big of a result, which gave us the conclusion that there was still just a little too much moisture in the room to get a clear result.
So now we can talk a little bit about some measurements. So we were able to measure the length of the tape, which was 20 centimeters, as well as the width of the tape, that was 1.27 centimeters. Then we were also able to calculate the density, which was 0.08 grams per centimeters, as well as the mass, that was 0.00016 kilograms. Then we also wanted to figure out the weight force, and we calculated the weight force by using Fw equals mg. We multiply then the mass by the the gravity, which gave us 0.568 times 10 to the negative third newtons. As we said previously, the distance moved was 0.05 meters. We also were able to find the approximate charge that ended up being 2.1 times 10 to negative 8 coulombs. And then we computed the charge with the formula F net. And then once we got the charge, we divided it to the elementary charge to get the approximate charge. So lastly, we calculated the total numbers of atoms by adding the calculations of the area divided by 2 angstrom of the length and the width. And then we made a ratio with the number of electrons to the number of atoms. We also need to be mindful that we assume that one atom is 2 times 10 to the negative minus 10.
Thanks for watching!